Ever wondered what would happen if we could travel as fast as light? Imagine for a moment a world where the laws of physics as we know them are stretched to their limits, where the impossible becomes possible. This is the world of faster than light travel, a concept that has fascinated scientists and dreamers alike for centuries. The idea of faster than light travel, often abbreviated as FTL, is purely hypothetical. According to the special theory of relativity, only particles with zero rest mass, like photons, can travel at the speed of light. But what if we could? What if we could break this cosmic speed limit imposed by the universe? In the realm of the theoretical, there exist entities called tachyons. These are hypothetical particles that, if they existed, would travel faster than light. Their existence, however, would violate causality, the principle that cause precedes effect. In simpler terms, if tachyons existed and we could harness we could potentially time travel. Yes, you heard that right, time travel. But before we get too excited, it's important to remember that tachyons are purely theoretical. The possibility that there could be particles out there that break the rules, that exceed the speed of light, that could potentially let us travel through time is fascinating to think about. As we embark on this journey of exploration, we are venturing into the realm of the hypothetical, the unknown, challenging the laws of the universe as we know them. Stay tuned as we delve into the time it would take to reach various celestial bodies at the speed of light. So buckle up and let's prepare to journey beyond the speed of light. Imagine embarking on a journey to the moon at the speed of light. Now let's put that in perspective. Conventionally, a spaceship traveling to the moon travels at speeds of roughly 5,000 miles per hour. At that speed, it takes about 3 days to reach our celestial neighbor. That's 72 hours or 4,320 minutes. Quite a long time, isn't it? Light travels at an astonishing speed of approximately 186,000 miles per second. Yes, you heard it right, per second. Now if we could harness this incredible speed, the 3-day journey be over in a flash, literally. The distance to the moon is about 238,900 miles. At the speed of light, we would cover this distance in just over 1 second. Yes, in the time it takes to snap your fingers, you could be standing on the moon, looking back at the beautiful blue sphere we call home. What about the sun, our closest star? How quickly could we reach it at light speed? Let's put this into perspective. The sun is about 93 million miles away from us. Now, if we were to travel at a conventional speed, say the speed of a commercial jet, it would take us roughly 200 years to get there. Yes, you that right, 2 centuries. But let's switch gears and imagine we could travel at the speed of light. Light travels at an incredible speed of approximately 186,000 miles per second. So if we were zipping along at this cosmic speed limit, we could traverse the vast distance to the sun in just about 8.5 minutes. To give you a sense of how fast that really is, in the time it takes to boil an egg, you could have already reached the sun and be on your way back. It's mind-boggling, isn't it? Let's expand our horizons and consider a light-speed tour of our entire solar system. Picture yourself stepping into a light-speed vehicle, buckling up, and embarking on a grand tour. Our first destination, our closest neighbor, Venus. At conventional speeds, it would take approximately 6 months to reach Venus, but at the speed of light, it's a mere 2-minute trip. Subsequently, we'd set course for Mars, the red planet. A voyage there using current technology could take anywhere from 6 to 9 months. However, at light speed, we'd be there in just over 3 minutes. Remarkable, isn't it? From Mars, we'd aim for the massive entity of our solar system, Jupiter. A trip to Jupiter today would take a staggering 6 years. But at light speed, you'd barely have time to enjoy a cup of coffee, as we'd be there in marginally over half an hour. We'd proceed with our expedition, visiting Saturn, Uranus, and Neptune. These distant planets, which would take years to reach with existing technology, would only be a few hours away at light speed. Saturn in an hour and a half, Uranus in 2.5 hours, and Neptune in slightly under 4 hours. Lastly, our ultimate destination, Pluto. Despite it's no longer classified as a planet, it's still an eminent member of our solar system. A mission to Pluto using the most sophisticated technology today would take almost a decade. But at the speed of light, it's a 5.5-hour journey. the enormity of our solar system becomes incredibly accessible when we travel at light speed. Now, let's venture beyond our solar system. How long would it take to reach another galaxy at the speed light? When we think of distances in space, we often use the term light year. A light year is the distance that light travels in 1 year, which is approximately 6 trillion miles. For perspective, the distance from Earth to the Sun is a mere 8 light minutes. So let's set our sights on our closest galactic neighbor, the Andromeda Galaxy. Andromeda is approximately 2.5 million light-years away. Yes, you heard that right, million. This means that the light we see from Andromeda today actually began its journey over 2.5 million years when early human ancestors were just beginning to use tools. If we hopped on our light-speed spaceship today and set course for Andromeda, the journey would still take us 2.5 million years. That's longer than the entire span of human history. In comparison, if we were to travel at the speed of the fastest spacecraft ever built by humans, the Parker Solar Probe, which travels at an impressive 200,000 kilometers per hour, the journey to Andromeda would take us approximately 3 trillion years. To put that into perspective, our universe is only around 13.8 billion years old. The journey would be over 200,000 times the current age of the universe. So, even though light speed is incredibly fast, the vastness of space is just, well, vaster. It's a humbling reminder of our place in the cosmos. So, for now, we'll have to satisfy our galactic wanderlust with the help of powerful telescopes and the marvels of modern astronomy. So, what does all this mean for the concept of faster-than-light travel? Let's dive in and explore. Let's consider the energy requirements for light-speed travel. To propel any object with mass to the speed of light would require, in theory, infinite energy. This is due to Einstein's theory of relativity, which tells us that as an object approaches the speed of light, its energy requirements increase exponentially. This presents a significant hurdle for any potential light speed or faster-than-light travel. Let's not be discouraged just yet. There are theoretical possibilities that could allow for faster-than-light travel without violating the laws of physics. One such proposal is the Alcubierre drive. This concept, named after physicist Miguel Alcubierre, suggests that a spacecraft could effectively warp the fabric of space-time around itself. By creating a bubble of space-time that contracts in front of the spacecraft and expands behind it, the Alcubierre drive could allow for effective faster-than-light travel, while the spacecraft itself remains stationary relative to its immediate surroundings. Another theoretical proposition is the concept of Krasnikov tubes. These are hypothetical structures of warped space-time that could allow for superluminal travel, essentially serving as shortcuts through space. Similarly, traversable wormholes, if they exist, could potentially provide a direct route to distant parts of the universe, circumventing the need for light-speed travel. Lastly, there's the phenomenon of quantum tunneling. This is a quantum mechanical effect where particles can tunnel through barriers that would be insurmountable in classical physics. Some scientists speculate that if this effect could be harnessed on a large scale, it might provide another potential avenue for faster-than-light travel. The prospect of faster-than-light travel is currently speculative. It's a fascinating concept that continues to capture our collective imagination.